everybody. It is Tuesday, April 28th. Another beautiful morning. Today I'm going to show you some properties of logarithms and then how to do them and some problems. The properties of logarithms, they go both ways. So the first property I'm going to start off showing you is we have the product rule, the quotient rule, and the power rule. So the product rule, if it's a product, it gets sent to addition. If it's a quotient, the quotient rule, if it's division, it gets sent to subtraction. And then if you have any exponents, the power rule says any exponents can be thrown out in front of the log. So what we have here as far as the formula is multiplication, the product rule. Multiplication gets sent to addition. So this would go log A subscript log subscript A m plus log subscript A n. Multiplication gets sent to addition. Division gets sent to subtraction. So, and whenever you send it to subtraction, the numerator, the guy on top, has to be written first. So this is going to be log A m minus log A n. So make sure when you send the quotient, the division, to subtraction, that the numerator, the guy on top, gets written first. If it doesn't get written first, it's going to be incorrect. And then the power rule says that if you have any exponents, the exponent can be thrown out front. So this would be P log A m. Alright, so those are the formulas of the product rule, the quotient rule, and the power rule. Alright, so the other thing before I start doing a few problems is you need to know that any radical root can be written as a fractional exponent. So the square root of x is the same thing as x to the 1/2. The cube root of y squared is the same thing as y to the 2/3. And you'll need to know that to implement these properties that I'm trying to explain. Whenever you write a radical with a fractional exponent, the top number is always the power, and the bottom number is always the root. On a square root, we never write it, but there's a 2 right there. The cube root of y squared, top number is the power, this is y squared, the bottom number is the root. The cube root of y squared is y to the 2/3. The fifth root of z would be z to the 1/5. If you don't see an exponent on a variable or on a number, the exponent is always 1. So you need to know that. And now that I've shared the properties and how to write radicals, this is what your product, your example might look like. So say we have log 2, and then we have like x to the 4th, y cubed, z squared. Alright? Well, and they'll say, write the, express in terms of sums and differences. So if you have to express this in terms of sums and or differences, this is a product, and product gets sent to addition. So whatever the subscripted guy is, if there's a subscripted guy down there, which there is in this case, it's a 2, you got to write that throughout the problem. So we're going to go log 2 x to the 4th plus log 2 y cubed plus log 2 z squared. Alright, so I sent the product to addition, and now we have exponents. And what does the power rule say we can do with exponents? Well, any exponent can be written and thrown out front of the log. So this exponent of a 4 is going to get thrown out front, so we're going to have 4 log subscript 2x plus 3 log subscript 2y plus 2 log subscript 2z. So as I said, if there's a subscripted number there, you got to keep writing that subscripted number throughout the problem. This is logarithm that started out as a product, now it's written as a sum. Alright? Products, stuff that gets multiplied together, gets sent to addition. Okay? So now I'm going to show you how to implement the quotient rule. So say we have log, there's 3, and then I have the square root of x, y squared over z to the 4th, okay? Well, up here, square root of x, y squared, that's a product, and then I got a quotient too, so what I'm going to do, I'm going to write square root of x is x to the 1/2, alright, y squared, being very methodical here, minus, I send division to subtraction, log subscript 3 z to the 4th. So I sent the division to subtraction, and I told you whatever is on top has to be written first, has to be, alright? And then what we have here is this is a product, alright? What do we send a product to? Addition. So I'm going to write log subscript 3 x to the 1/2 plus log subscript 3 y squared minus log subscript 3 z to the 4th. And then I have exponents. And what do we do with the exponents? What we do with the exponents? We throw them out front. So I have 1/2 log 3x plus 2 log 3y minus 4 log 3z. And we took this single log and we wrote it as a sum or a difference. Alright? One more, and then this will be my last one for the day. These properties of logarithms, they work the exact same way for the natural log. So, say I have the natural log of square root of x cubed, y to the 4th, z. Alright? Notice it's a natural log, not a log. Well, the properties for natural logs work the exact same way. Alright? So, as a single natural log, we're going to write it with a sum or difference. So, we're going to have natural log. I'm going to write the square root of x cubed as x to the 3/2. Top number is a power, bottom number is a root. This is a square root. So, y to the 4th, z. Alright? And then, what is that? That's a product. Well, what do you send a product to? You're going to send it to addition. So we're going to have the natural log of x to the 3/2 plus the natural log of y to the 4th plus the natural log of z. And then we're going to throw exponents out in front, and that's going to be our answer. So we're going to have 3/2 natural log of x plus 4 natural log of y plus the natural log of z. And that is our answer. And then these products, these rules, they go both ways. So tomorrow I'll write a sum or difference, and we'll send a sum or difference back to a single log, or in this case a single natural log, and that's what we'll do tomorrow. Have a good